Hello, we've got a Physics Paper 2 exam question today, and this is from 2024, Physics Paper 2 Higher, and this is on the required practical 7, all about forces and acceleration. So a student investigated how the acceleration of a trolley varies with the resultant force on the trolley. The resultant force would be changing the mass here. Figure 10 shows some of the equipment used. So we've got a trolley attached to a weight which is on a runway, and that's going to pull down and then pull the trolley along. Figure 10 shows the force F which acts through the string, and that force is going to be pulling the trolley, and that force is called tension. Give one variable that should have been a control variable, so kept the same through the investigation. So we'd need to keep the combined mass of the trolley and the hanger the same. You can get a mark for just saying the mass of the trolley or the mass of the hanger, but it should be the combined mass. Part 3, the student held the trolley stationary and then released it. The trolley moved along the runway with a constant acceleration. The student recorded the time taken for the trolley to travel a measured distance. Describe how the acceleration of the trolley can be calculated using the time taken and the distance. So we are told that the student is measuring the time and measuring the distance, so we'll have those values, and we have to describe how we get the acceleration. We don't actually have to calculate it, we're not given the values, we just need to describe how we would do it. So the tricky thing with this question is that there isn't an equation that directly works out acceleration using time and distance. We have to first of all calculate the velocity and then work out the change in velocity. So these two equations here. So we're going to use this one first to work out the speed or the velocity, and then we're going to work out the change in velocity. I'll show you how to then figure out the acceleration. So step 1, we're going to divide the distance by the time. That's going to give us the velocity. That works off this equation, which is, so S equals VT, and that is distance equals velocity times time. So we've just arranged it to get velocity, distance over time. So velocity equals distance over time. So that's what we've done there. Now for step 2, we need to work out the change in velocity in order to be able to plug it into this equation. So the second equation we're going to use is, so I'll put it down here, acceleration equals the change in velocity over time. We need to work out the change in velocity. We've got the time value, that will give us the acceleration. Now, we can't work out the change in velocity with the values we've got, but we can work it out because we are told that the trolley is moving with a constant acceleration. That would look like this. So if this was time and this is velocity, constant acceleration would be a straight line like that. We've calculated the average speed here, the average velocity. So the average velocity is going to be somewhere in the middle between the slowest velocity and the highest velocity here. In order to work out the change in velocity, we would need to know the maximum velocity. So we can assume that the maximum velocity is twice the mean. If we double the mean velocity, we'll get the max velocity. And then that is going to give us the change in velocity. So now we've got our change in velocity, we can just divide it by the time which they recorded. That will give us our acceleration. That is a pretty tricky question for 3 marks, but that is the way that you do that. For one set of results, the force acting through the string was 2 newtons. The student released the trolley 3 times and determined the following values for acceleration. So we've got 3 values for acceleration. We have to calculate the uncertainty of the values. To work out the uncertainty, first of all, you calculate the range. The range in these values is 0.06 meters per second square. So that is the difference between the lowest and the highest. And then you divide the range by 2 to give the uncertainty. Let's just put it down here. So finally, we've got this part of the question. The runway was then raised at one end. So the runway has been raised up. The force acting through the string remained the same. Explain how the acceleration was affected by raising the runway. So the acceleration is going to increase, but that's not enough to get any marks here. You can't just write the acceleration will increase. We need to explain how it was affected. So it's not enough just to say that, unfortunately. Now, this is a very tricky question, and most students weren't able to answer this. But it's because, so what's going to happen is that before, all of the weight of the trolley, when the trolley was on the flat surface, all of the weight of the trolley was being pulled down by gravity. Now, when it's raised up, some of that weight is now going to be pulled parallel to the runway. So not all of it is going to be acting downwards as before. So that's the first mark, is to say we use the word component. A component of the trolley, a component of the weight, sorry, is now acting parallel to the runway. This has the effect of increasing the resultant force on the trolley, and that's going to increase the acceleration. Yeah, horrible question there, but I hope that helps.